Thank you for joining us, everybody who's logging in and getting situated. On behalf of the National Glass Association, I'm Sarah Neiswanger, the Director of Membership for NGA, and happy to have Michael Soroka with Gold Ray Glass. So before we begin, let's just go over a couple of other things on the horizon. At this point, I hope you are getting tired almost of hearing about GFAB, NGA's Glass Fabricator Conference, but it's important. And I did have some notes on this, but I'm just going to go off script for a moment. Um, if you haven't heard, this is NGA's inaugural year for the NGA Glass Fabricator Conference. It's not very often that you get to say that you can be in on something from its inception. This was based on feedback from fabricators over the last couple of years that, the realization that some folks were at one meeting and some folks were at another, and wouldn't it be nice to have everybody all in one place? And so this is meant to be that place. Specifically, that place is the Radisson Blue Aqua Hotel. It's a beautiful glass-clad tower in downtown Chicago, so we'll be gathering there June 14th to the 17th. And if you've been to NGA's Building Envelope Contractors Conference, the BEC, before that's a not miss event. And this year actually marked its 28th gathering. So just imagine what GFAB could also be in 28 years. That is our goal, to make this the BEC conference for fabricators. It's a great opportunity to introduce your new hires and your young professionals to the industry. It's also a unique chance for your plant personnel to get out of their plant for some specific hands-on training specific to their role. So next month in June, we hope you will join 150 of your friends in fabrication in Chicago. This number just keeps going up, and we hope that you are part of that growth of this inaugural event. And then finally, following GFAB is Glass Build America. It's hard to believe it's already just about 4 months away. Compared to past years, this trade show is being held fairly early in the season. So September 23rd and the 25th, we'll be back in Las Vegas. Attendee registration opens, let me see, sorry, June 25th, and exhibitor registration actually opens on June 2nd. There's a variety of new additions to this glass build, so I hope you'll make plans to attend. We have a dedicated keynote theater, so anyone with a ticket can come to any session, and those will be before the trade show begins. So you won't have to juggle booth time with, oh, I'd like to see this session. We also have a new association row that's going to feature a variety of our kind of parallel industry partners. So you can visit booths for FGIA, for AIA, NAHB, and a few more. So that's kind of a new and unique experience. There'll be an opportunity that we're calling Pause for Puppies. It's your wellness break, literally to visit puppies, and we're partnering with a local animal shelter to offer that. And then finally, we're offering a new youth registration category. This is to encourage you to bring all the young people, whether they're your children, they're high school students, anyone you're mentoring, or interns, expose them to the industry and all the cool things that they're going to see on the trade show floor. So again, June 2nd for exhibitor registration and June 25th for attendees. And now I am excited to introduce our speaker today, Michael Soroka. Michael is the Chief Product Officer at Gold Ray Glass. And though he wanted, this is probably more than he wanted me to share, I think it's pertinent to today's presentation. So Michael has worked in the industry since 1996. He has a penchant for technology, often drawing on what other industries are doing and how he can apply that to the glass industry. So with that in mind, Michael even engineered, coded, and supports Gold Ray's own ERP software. In addition, he's been instrumental in transitioning every manual process at Gold Ray to an automated one in a way that supports the factory's operation with delivery that's consistent and client-focused. So at the NGA, Michael is the technical liaison for the decorative glass and mirror technical segments, and those are based within the fabricating committee. And he's also who chaired the glass nomenclature task group. So with that, Michael, welcome. I'll let you take the controls here in a moment. But just before we get right into the presentation, let's take one more step back about how we got here. You're about to go in depth on a technical paper and a web tool that was developed by an NGA member volunteer task group. Um, Tell us about this. It looks like it could be a real game changer. What's the prequel in terms of, did this come up like a lot of ideas do around a booth, on a napkin, or what's that story?
Oh, okay. You're right. A lot of time, a lot of the great ideas happen outside of the session. This one actually happened inside. I think I can't remember the conference it was, but it was one of the tech conferences, and SGCC was playing with a way to codify laminating makeups and standardize how laminated glass was labeled. And at the time, we were writing the laminating glazing manual, and so we were going to put that in the laminating glazing manual. And I kind of saw that this is such an awesome opportunity to expand on that, and let's start standardizing how we write glass makeups, specifically dealing with software and computers. I think all of us in the industry have seen specifications that make no sense and glass descriptions that are contradictory to themselves. And that's not a real great way when you start dealing with software and when you start dealing with tools. So I kind of volunteered to take this on, having the background I have to say, this is exciting, and I want to chair this. And so it's actually Julia Schimmelpenny let me, which was wonderful. And we got a whole group of people together to start really discussing what is it that we're making and how do we define this. Um, I'm kind of liking some of the new directions we're going on the industry defining how we communicate digitally as opposed to putting all that burden on the software companies who have to guess what we do every day. I think it's only fair for us to tell them. And so this was a really fun group, and I enjoyed doing it. And we also wrote it knowing that we're only 80% there, and then round two is going to be another 10%. Round two will be another 5%, and making sure that we can keep adding to it as adoption increases. So it was really fun. I enjoyed it.
Terrific. Well, why don't you walk us through what it all entails?
Okay, sounds great.
Mhm.
So the glass nomenclature. So we're going to go through the structure of how we define glass types. And then in the end, we're going to do a quick demo of the tool that we built, because it's one thing to see it on paper, but really to understand it, you need to play with it. And so on NGA's site, the tool is up there for both writing and decoding glass makeups. And so it's really our first step at building this and getting industry feedback. So, like I said, we've got a lot of descriptions that we come across. You can see the human descriptions. All three of these mean something to us, and all three of those things mean the exact same thing. And where, again, if we're getting into software, we're getting into coding, we really need a defined product. And so, all of these descriptions over here that are human descriptions using the nomenclature format would be defined as this. It's one line. It can be broken into chunks, and we're going to go through this chunk by chunk just to really show that it actually is really easy to digest, even though it is more intended for electronic and categorization. You absolutely could use it for anything. So first thing is thinking is The analogy is a shipping label for glass. Like when you're filling out a shipping label, you don't describe how to get to the address. You don't say it's the fifth house down from the big elm tree. We have very specific things. This is the house number. This is the street. This is the city. This is the state. This is the country. This is the code. And so we're doing the exact same thing, but with a glass makeup. We're saying this is the glass type. This is the airspace. This is the structure. This is the order it goes in. And so it's just a defined structure more than anything. The nomenclature just tells you how to write stuff. It's not a set of rules what can and can't be used. It's purely this is how you submit the information. So as we look at uh, the example that we have down here, we have uh, it can be broken into chunks. So this right here is the light, a glass. We can describe surfaces on it where, and we'll get deeper into this, but how do you find something is on what surface? We have the makeup and the interlayer section, or how something looks as it's insulated. And so these are really the four sections that get defined in the structure. So you see it isn't spacer bar, it isn't cut sizes or fabrication. This is purely just the glass makeup. We decided to use metric for this. This was a decision made earlier, and we agreed to continue with it. The reason being is we wanted this to be meaningful globally. So if we define a standard, we wanted to make sure that it's what the majority of the world uses, not the majority of North America. So again, so we're outboard light, 6 mm, half-inch airspace, 6 mm. So that was an intentional decision. Also, metric is a lot easier for software to develop or to digest than fractions are. So we're going to go through the chunks. So the first thing we're going to do is the basis of any glass makeup is the glass. So the smallest piece in here is here's the thickness. And sometimes that's enough because if we don't have a glass type or we don't have a kind, it's by default clear annealed. And so just a 6 would be 1/4 inch clear annealed. In this case, we've got 6 fully tempered, so that would be 6 mm clear, fully tempered. We could put annealed if we want to clearly call it out. Again, heat strengthened, fully tempered, chemically strengthened, and brought these codes over from ASTM C1048. So we wanted consistency in our structure versus the standards that we all refer to. After that, we can also look at the type of glass. So like again, I said clear is the default, but again, you can clearly define it if you want to be very explicit that it is clear. We also have low iron. There was a lot of conversation around mid iron, but we did choose to keep it. Bronze, blue, or if you're doing plastic glazings like polycarbonate or acrylic. And so, like I said before, just a number 10 can be 10 mm clear annealed. I don't know if you guys can see my cursor when I'm presenting, so I'm just pretending you can, but I'm actually pointing at things on the screen. If not, then I'm doing it for my own sake.
No, we can see it, Michael.
Pardon me?
We can see it.
Okay, good. But I'm not using my finger, so that because I know for sure you wouldn't see. And then 6 mm polycarbonate would be listed this way. And so the order that they're listed in is important. And so that's why you have a structure. So we can see its thickness, the type, and then in brackets, um, uh, the glass material. So next, as we have the glass, then we can define if something is on a surface. And so we know we have surface 1, surface 2, we have an inboard, we have an outboard. And so what we've decided was If the surface code comes before the thickness, it's on the outboard surface. So 1, 3, 5, 7. If it's on trailing it, then it's going to be on the inboard surface. And so again, it's visual um, when you're looking at the code. So it still gives sort of human feedback on what that looks like, and you can tell visually um, that this is going to be acid at surface 1 or reflective on surface 4. And I knew that those were there because here is the table. So we have low E reflective code. I said reflective, I should have said mirror. Um, so we have a low E reflective coating. We put a star there, and we'll go through why that is near the end. But we try to take the code. So whether it's mirror, acid etch surface, fritted surface, digital print, a paint or roll coated. So these are all the codes that we came up with for um, what could be done to a surface. Uh, we can expand on these later as required. Right now, if you look at the technical paper, it says Schema 1, and so that's essentially version 1. Um, it's written in a way that we can expand on it later with the intention of being backwards compatible. So if we write a schema 1.5 or 2, or then it should be able to read previous versions correctly. Um, and then last, what we have is this double asterisk, and that has to do with if you use a low E reflective coating, how are you specifying that? And so when we look at the third example, it's going to be 6 mil heat strengthened, low E on surface 2, and then the whole makeup trails with a double asterisk and then has you can specify the coding after the fact. And so it knows that the first one listed is going to be, this could say double silver, low E. It could be the specific brand that you're specifying. Um, but it allows you to have different codes. You could have a 1-inch unit with different low E and still be able to specify it by changing the trailing um, descriptor of that coating. Above it, we have, again, 10 mil tempered, low iron, acid etch surface 1. This one, we have 6 mil clear annealed. It doesn't say the type or the material, so we know it's clear annealed with mirror on number 2. So this is how these would be read. Next, laminating. So this is where the whole thing started. So we've gone through monolithic lights. A laminated light is going to be treated the same. So what we do is we'll define this light, we'll define this light. They're separated by commas, and then at the end there's a trailing dash with an interlayer code. And so in this case, we're going to have 6 mil tempered with 6 mil tempered, 6 mil clear tempered, with a 1.5 millimeter thick PVB interlayer. And so when we have the dash, it's always thickness, then material code. And then, so essentially here's the visual of it, but we can group it in there. We could have multiple, it could be 666 with one interlayer or multiple interlayers. So, and I believe I have an example of that. So here are the interlayer codes that we've used. These codes also were originally in the original SGCC document. We've kept all of those codes and brought them over into this because really we took all of their hard work and adapted it. So again, we chose to go metric. And so here we have, and again, whether it's PVB, ionomer, TPU, All of these things really define, this is the table for the different materials. So, like I said, we can do multiple. So if it's 6 mil clear annealed on clear annealed on clear annealed, but they all have the same interlayer between them all, you only have to specify it once. It's just assumed that all interlayers are this. If it's different interlayers, then after the dash, the interlayers have a comma separating them out as well. So we could say that this is a 1.5 millimeter PVB, and then the second interlayer is actually going to be a 2.3 millimeter. So if that's intentional, maybe the backlight has texture to it, and we need to thicken up that PVB so that it forms to that texture. That can be specified here intentionally. Although it doesn't have a texture because we did not put a character after it. Again, here is glass-clad polycarbonate. So we've got glass, polycarbonate, glass with a urethane interlayer, and it's just assumed that it's urethane between both lights. So those are all the building blocks to make a monolithic glass or laminated glass. Now we might need to make an insulated glass unit. So we separate either the monolithic or laminated glass uh, descriptors with an airspace, and we use the square brackets to say that there is a gap here. So actually, the square brackets really look like an airspace, and actually oops, oh, I'm going forward, not backwards. The dash actually looks like an interlayer. That is a good way to remember it, but I'll be honest, was not intentional. That just happened. So in the airspace, we're going to again break it up with similar structure as glass and interlayer. Here's the thickness. Here is the material, or in this case, the gas. So we're going to have a 12.7 millimeter gap, which is 1/2 inch, and argon. And then again, we've got these codes um, specified for the gap type and the gas or vacuum being lack of gas. The current structure does not allow for gas blends. There is a concept in the calculator if you want to use some preview features that we've got an attempt to address that, but it's not in the official documentation, but just something that is in there to play with so that when we get to the next round of working on this document, we can decide if that's the direction we want to go. So here we have, um, again, a full insulated, laminated makeup. But again, all we got to do is to read it is break it in chunks. Outboard is 6 mil fully tempered with low E. 1/2 inch argon airspace. Inboard light, heat strength on heat strengthen with 1.5 mil PVB. So it's easy to read if you just break it up into sections. And when the computer breaks and decodes it, that's all it's doing as well. It's breaking it into sections, breaking those sections into their components and reading it. So here are some easy examples all the way down to a triple IGU. So again, it's easy to break up. Here we know we've got an outboard laminated light, airspace, thin glass middle, another airspace, another inboard laminated light. And so really easy to read once you get used to it. There's a quadruple lamy all with 1.5 mil PVB. Okay. So, Sarah, do we want to go through questions before the demo?
Yeah, sure. I don't, let me get my video turned on here. I don't see any in the chat just yet,
Oh, okay.
but I will tee us up with something. You know, you and several others built the tool. How do you use it so far?
Actually, I actually used it last week. I was using the LBNL, the optics program for build. I had to build out a laminated file before I could bring it into Window to do the calculations. And I'm like, oh, now I know how I'm laminating, or now I know the product code that I'm writing in for that laminated light. So I actually um, use it specifically for that. We do also have customers that want to send us their orders electronically. So their system ties into our system. And quite often they say, they're like, I need to know the format that you can read. And so in this way, we can instruct them here's how you structure it. Probably because they're another manufacturer and not a glass company, I would say, here's your codes for these products that you use.
Mhm.
But then I can take it, I can digest it, and it's enough for them too to say, oh, if I need 10 mil instead of 6 mil, I'm like, yeah, just change that to a 10 mil and we can read it. And so um, we work with a good number of companies that send us files electronically and they're automatically put in our system and we schedule them and stuff pretty much instantly. So this structure allows us to have a uniform system. My dream is that the industry has a standardized way of communicating. We're early in that stage, but I think I said we're in a way we're sort of field of dreaming it. It's if you build it, they will come sort of scenario. Um, uh, and I'm happy that it's the NGA building it so that it's an industry specific as opposed to a specific company.
Yeah, no, we appreciate you using all of our volunteers using NGA as a vehicle for this. So we do have a variety of things, questions and comments that have come in. First one, was there any consideration for heat soaked? Although rarely, they've seen HS used similar to heat strengthened.
It was not, but it's a super good idea to look at on the next round. And I think like any paper, I think sending those ideas into the NGA staff is the perfect way for them to add it to the list so that the next time we get together, we can start working on it. And
Mhm. Yeah.
honestly, the more requests, the better. That means there's interest. So I hope we're flooded with ideas.
Good. I know Karen Wiegert from our technical team's also on the webinar, so she's listening intently, I'm sure. Another question, is the assumption on the insulating examples that it's 90% argon?
There, actually, no. And actually, if you look at the IGDB gas things, they have 100% and a 90 mix as well. So the assumption is 100%, but when we get into gas mixes, it certainly could be added that way. And I think I'll re sort of repeat too that this is a structure to put information in. We don't want to tell people what they're doing or how they do it, or but really saying this is just how it could be communicated. So this is a
Mhm.
communication tool of how you structure info more than kind of putting limits on what that information is. So I know that 90% is super common, but um, I would, again, and the industry could come back and say, we want this. Like we put other assumptions in here too, saying that if no code is in there, it's clear. No code is in there, it's annealed. Um, if
Mhm.
it comes back that we meet about this and say, hey, this needs to cover 90 to 100% of this thing, and that is how we want to do it, then absolutely the industry can go that route.
potential to at least specify a default if needed.
Yeah.
Um, all right, another question. Why did you decide to put the interlayer at the very end of the laminate description rather than put the interlayer abbreviation in the sequence of the constructed laminate?
It's a good question. One, we inherited it, but two, also thought it was a good idea because when you look at those triple laminates or quadruple, and we want the same interlayer, it only needs to be specified once. So it keeps the code shorter and a little more concise. So you have the option to do it. And so that was really the feeling on it. So those
Mhm.
kind of those two reasons.
Okay. Another one, how do you identify the specific type of low E or differentiate between manufacturers?
Okay. So when you have the star on after the six, we'll say, so we're going to say that the low E is a number two. At the very end of the makeup, when you use a star, you have a double asterisk at the end where you list the low E type or reflective type after the double asterisks. They're in the tool, and I'll try to remember how I did it. There is a conceptual low E table with some low E codes that we right now there isn't an industry standard um, low E catalog, and so even when we were building this, we're thinking, oh, let's just use IGDB, but there isn't one. They don't have a code for the low E. They have a code for the whole glass type. So this low E on this thickness, on this, whether it's low iron or clear, has its own ID. And so there's no real way to differentiate. Um, so right now it's a write-in after the fact for people. They could use their own internal coding system if they wanted to. But again, pipe dream. We have a standardized low E table that we can start building codes for manufacturers and test it out. So that is in the preview as well. When I wrote the tool, just as a sort of a conceptual way. But so right now, the answer to the question that was asked is at the right after the double asterisks.
Okay, sounds good. Um, Another question, any consideration for signifying the various types of PVB interlayers versus just B?
Uh, I would say we did not think of it. I think the first approach when we wrote this is sort of a walk before you run type of scenario. Let's build the structure and see what kind of feedback we get so we know which direction to go. There's certain ways that we could approach that pop in my mind, but again, that would be a thing that if it was important, let's say it's acoustic or it needs to be this particular manufacturer's acoustic, maybe we can look at something similar to a standardized Lowy database, and so we certainly could maybe have a generic format that could be expanded to a specific one. And I don't think that would be difficult, and it would still be backwards compatible. So,
Mhm. Another question just came in. When it's different types of glass, like rain or reed glass, is there a code for that?
oh, what a good question. Um, there isn't. I think we should probably come up with that. Maybe off the top of my head, if we say there's an asterisk, then following the double asterisk is the low E. Maybe we put a double T and we can list it. So if it's
Mm.
reed laminated to narrow reed, we could list that in a similar fashion. So that off the top of my head, I would approach it that way. But no, there isn't.
Okay, well, we're getting a lot of ideas
Yeah.
so far. And then one final item, it was no question here. This is also a hello uh, from Kevin at Rice Engineering, but he is asking, should we start adding these to our engineering calculation packages?
You know what? I hope that people see value in this, and I think that would be awesome. I think I would love to see software manufacturers adopt it as well. I think engineering, I think it would be great. I'm using it internally. I was on the task group, so I had a bit of say in in how this went. But
Mhm.
honestly, we were handed a really good starting point. Um, I would say if you guys find this useful or meaningful, I say let's use it.
Awesome. And then I think one more comment or thing to ponder. I think LBNL NFRC ID would be ideal, although each LBNL ID is unique and should align with the substrate thickness and the coding. So it would be worth discussing if it makes it easier for simulators.
It, I think so. I think it would be really neat if next time we looked at another revision, we invited them to join the task group. Because wouldn't it be awesome to say, here's my product code, I submit it to a web service that digests it down, and instead of using the window program, they have a web service that can break out the makeup and calculate it for you. And um, then we're doing things on the fly. I think the whole intent of automating and taking out manual work out of the stream. I mean, everyone is we've been talking about not having enough labor and not being able to find the right people. And so I think keeping the people that we do have doing the work that humans need to be doing and things that we can maybe automate through a process can be done that way is going to be better for everybody. And so I would love to invite them to the next task group to see if they were interested. And um, man, wouldn't that get the use of this code adopted quick if they were on board?
For sure. And you have another task group volunteer already. So thank you, Raymond, for being interested in this. And if anybody else, member of NGA and fabricating committee, we'd love to have you involved for the next iteration as this grows. So I think that's all of the questions for the moment. If we want to move on to the demo, and then we can, if anything else comes up, we can answer more questions following.
Wonderful. Okay. There's my mouse. Okay, I'll stop sharing. And I was not smart enough to preload this, but that almost works in everyone's favor because now I'll tell you how to get there.
And in the meantime, I did put a link to the tool in the chat, at least as it directs from glass.org.
Perfect.
And then, Michael, while you're pulling that up, this does, a glass technical paper does accompany this that explains kind of the background and how to use it, correct?
Yes, there is a link in there for sure.
Mm.
All right, now share again and pick the right screen. You guys don't need to see my email or banking information. Okay, does everyone see the website?
Looks good.
Okay, so if we go to education and go to, it's in the technical resources, there's glass nomenclature tool. And so there's two components in there here. There's a builder and there's a decoder. So the first one we're going to do is a builder. I think as we look at making codes, when you go to it, it sort of has this basic or a basic IGU sort of defaulted in there. And so right now it's making this code down here, this 6 mil heat strength and half-inch air with low E on 3. And you can, and again, as we can see, this double asterisk is saying low E, which is on our second light. But we could easily put, we could say solar band 60 if we're really specific about it. And you'll see now the code says solar band 60. So if you want to be specific, that is really the best way to do it. What I'm going to do is this reset builder is going to reset it back to a super basic one light unit, it's 6 mil clear tempered. And so on this case, let's say we're going to do a laminate. So we've got this light. Well, I'm going to add an interlayer. And then it breaks it into a laminated glass makeup, where it's got a glass light, an interlayer, and a glass light. And so now um, it's got, hey, someone needs to fix something they fixed. So now we've got 3 lights of 6 mil clear. Let's say we want to get rid of that third one. If you just click on it, it's going to delete the glass light and the interlayer. So now we're back to 2. Um, that was not intentional, but now you guys know how to get rid of a light if you add one by accident. So in this case, we're going to say it is 6 mil, but you know what? It's actually, it needs 6 mil low iron. It's going to be 6 mil low iron. The interlayer is going to be ionomer. And again, as we come back down here, you can see that it's now changed the code. And so this is the code that we're getting as we build it. And there's also giving a glass description down here that this is what's called a pipe delimited description. Those straight up and down lines are called pipes for those who didn't know what that little symbol above the enter key on your keyboard is called. That's what it's called. So as we build this, we could also turn it into a sealed unit where we're going to add, again, 1/2 inch air. Let's go argon. And for the sake of, let's go 90%. And then now here is air at 10%. This is that the reason that popped up is because I'm using the preview tool. And so this was my conceptual idea for doing gas filled. So you can see argon 90, the rest being 10, because in the paper, if you don't list the gas, then it is automatically air. But if we want to do 10% krypton, I don't know if that's a real thing or not. But I know that krypton's a real thing. I mean, the gas blend is a real thing or not. Then you can see that it add the krypton in front of the 10. So that was sort of an idea for the next round to do gas blends. Again, if we just change it back to 100, that part will disappear. And then front surface, we're going to add our coding. Coding is going to be low E because we're going to be supplier agnostic. And because we did the laminate low iron, it makes no sense for the import light not to be low iron. And here we have the coding. So if you want to make a code or see what a code looks like, this was a tool. And the reason that I built this tool really was just to be able to visualize what the paper is describing, because there's only so much you can do in words. So this tool was built really just as an example. So the other thing we have, I say, is the parser. And so what you can do, and so there's a builder, actually decoder, is and here's some starting examples if you want. I took the coding or the one that we just built, we brought over, but these are some starting examples. If you click on them, you can see it will change the text down here. So in this case, you can write your code, hit parse, and then it will build out the glass description. So if someone sends you a code and you want to know what it is, you can just punch it in here. And so, and again, there is no limit to what you want to do. If you're like 0.7 mil glass, then it's 0.7 mil glass. And so, again, the structure doesn't define what you can type in. It just is defining how you communicate it. So here's some super thin glass on the outside of some 10 mil clear. It's a laminate that's going to fit in the channel that can only take so thick a glass. And so that is how this tool is used. There is this is kind of outside of the scope of the presentation, but I will, just in case people are playing with it right now, I'm asking for a description. What I'm really hoping to do later is this is again just something I'm testing that people can write in a description and we can get sort of a basic specification written. This is not fully built out. If anyone goes into it and says, hey, this is wrong, my answer is going to be, you are correct. But it is something I'm hoping to build into the tool as we go, just as something that can be used, especially for some basic use. Um, Also, as I was building it, there's a lot of things missing. Believe it or not, standards. We have products that don't have standards, and so it was really hard to build out certain things for specification. So that could be something we work on next. Um, I know I went through that really quick. Honestly, I advocate everyone go in there, play with this. Um, Absolutely beat it to death. If there's some tech people out there that are like, I want, can this do this? Uh, if you go to glassnomenclature.com, there actually, you can see there's a builder and the decoder. There's some preview functionality. You can get some of the different things. Here's my stab at some low E codes if you want to play with that. Um, there also is an API. And so if you're really a geek and you want to be able to do this uh, in a process flow, like off the computer and instead of manually in the browser, there is the ability to put in a code. Here's what it would look like, and then here's the breakout of what you're going to get back from the software. Um, so again, I'm throwing this out purely for computer nerds. Okay. So Sarah, I think that's all I got, unless there's more questions.
I don't see a question yet. I guess I just wanted to confirm based on a comment in the chat. Should the tool, I guess, if multiple browsers are open at the same time, you and me, it should operate independently and maybe not show your work per se on my browser, correct?
It should be a local session, yes.
Okay.
If someone's in it right now and all my stuff is showing up on their computer, I really need to know that. But it shouldn't be. It should be local.
Okay. We'll get back to you on that. While folks may be thinking of any final questions, um, I have one, at least at the moment. Looks like others are playing with it and it's working for them at the moment. So that's good news. So how, like when you were implementing this at Goldray, how did this change did it change your company's processes, in terms of receiving, processing, who needs to adopt this
Oh,
downstream at your company?
so we internally, where I would use this is if you have part numbers in your software, it's a great way to identify, say, a product you sell, and then here is the part number, your CRM or things like that. Um, I think one of the reasons why I was excited to take this over is Goldray does have a structure for its products. Our products are, I'd say, non-traditional. And so when we were building this out, I was very, very intentional not to take the way we do it and put that on the industry. I think running a task group, you almost got to remove yourself as a contributor in a way so that it is the industry doing it. But one of the things that we did the same thing where kind of told everyone internally, this is a part number, this is for the computers. You don't have to learn it. The product team is just using it for making sure our systems talk to each other. And we did that so that the systems talk to each other. And that is sort of a wildly important. We went from a company that probably had 20 or 30 data sources 10 years ago into one unified system today, and that was intentional. And part numbers are very important. What we weren't expecting, because people were very scared of like, I can't learn that. I don't want to learn that. My job is to do this. And like, you guys don't have to, don't worry about it. And as soon as that fear went away, all of a sudden people were like, "Oh, I can read that. I know what that means," and sort of adopted it. And so um, we uh, we have internally something we call as our product Bible, and it's very similar to the schema document. That this is our product. This is how we talk about it. This is how we enter it in the system. And it added a lot of clarity too when products came in. We're like, well, how do we define this? And so it made all our information a lot cleaner, which is every company goes through it. Any system you have, the more you enter, the dirtier your information gets unless you're constantly focusing on making sure you clean that up. So we went through a process with a different structure, but my intention is to build this into ours, especially when we're communicating externally. So I can accept orders from my customers using a standard system. And um, that is sort of the intention as we move forward and as we work with other customers who ask to communicate with us.
Mhm.
Because actually our product codes I want to keep internal. So having this is actually also nice in the fact I can have an external request for product and not give away certain things I have internally.
Okay. Well, and I think that comment leads in maybe nicely to the next question. In general, was the goal to standardize the nomenclature used throughout the industry, or what if a specifier fabricator already has a nomenclature they're satisfied with?
So uh, it is a voluntary standard. And so what it is we wanted to offer a solution that if people want to use it, they absolutely can. Or, I mean, if someone has their own system, I am one of them, at least to understand what is out there and know that if an industry is now starting to talk a certain way, just know what they're talking about. It's like I'm Canadian. All our glass thicknesses are metric. Our sizes are still quite often inches, but our thickness is in metric. And I'm not going to reject an order for quarter-inch glass because we do 6 mil. So we're already speaking two different languages, but are able to understand, and I think is really just an extension of that. I, there's no there's no authoritarian sort of movement for people to change how they do things internally, but just hey, this is a way that we can all describe things, and it's there if you want to use it.
Okay. Terrific. Nice summary. Well, we had one person write down, thanks for the information. I'm not a techie, but glad to see the standardization. So hopefully everybody on the call at least sees an opportunity or a place that it would be helpful in their businesses. Um, and as one individual just pointed out, just like a model energy code template or ASTM 1036, for example. So there are other examples out there in the industry to compare it to. Um, as we're nearing the end of time, Michael, let's see. And also just to compare, there is a generic nomenclature for the steel studs through SSMA and SFIA. So it sounds like this is being used in other industries as well.
Oh, cool. Good. It's hard being first, but it's nice being second.
Yeah. We'll have to look into that
Yeah,
for comparison's sake. So let's see, Michael, if you wouldn't mind throwing the slides back up.
sure.
Um, we'll just close out and thank everybody for spending part of your afternoon with us. And a reminder, we're recording this webinar, so it will be available on glass.org/webinars by tomorrow midday. And if you haven't been to that website in general yet, I hope you'll browse. That is our library um, of our past webinars as well, so you can catch up on anything you may have missed previously. And as is shown on the screen, there is a QR code that takes you to the nomenclature tool as I pasted in the chat earlier on glass.org. And we hope to see you again at some of our next webinars. With Glass Build coming up, there are some targeted webinars taking place to make sure our attendees and exhibitors are well equipped. Our next Thursday is June 18th, and that will focus on the window and door industry's quarterly manufacturing report. So if that applies to you, we hope to see you there. And otherwise, we'll see you online and maybe even at GFAB next month. Have a great afternoon. Michael, thank you for spending your time with us and educating us on this tool.
Of course, if people have questions, they're welcome to reach out to me. And if they have ideas, absolutely, Karen.
Yeah, okay, sounds good. Have a great afternoon, everyone.